Here we're going to look at a geometry-related proof question. So we need to prove that any triangle with lattice coordinates on a 2D plane has a rational area. So keep in mind that lattice coordinates basically means coordinates with integer inputs. For example, 2, 4 or 2021, 1 or anything like that. So let's see what we can do here. First, let's just suppose an acute triangle. Don't worry, we're going to take care of the case of an obtuse triangle later, with coordinates of its vertices being a, b, c, d, and e, f, where all of these variables are integers. Next, we can draw a rectangle which overlaps within the vertices of the triangle. And let me just shade the original triangle in green right here. Notice that we can calculate the area of our triangle right here by subtracting the area of the rectangle with the area of these three blue triangles right here. Now, in order to save time, I've written some of additional coordinates and some of the distances that we're going to need for our calculation. So first, let's just calculate the blue triangles. So let's start off with this one on the left. Notice that the area will be a half times e minus a times f minus h. Now it seems that we're going to deal with like a bunch of variables, which will be kind of messy, but let's just take a moment to notice something right here. Notice that e is an integer and a is an integer, as well as f and h, so therefore each of these inputs are integers. And therefore the original area must be a rational number, since we have a rational multiple on the front. We can do the similar thing for each of these areas. So perhaps I'll just do one of them right here. We have a half times d minus b times c minus a. Both of these terms are integers, so therefore the resulting area is rational. For the same reason, since we have a multiple of a half on the front. And what we can conclude here is that the sum of the blue areas must be rational. And it then reduces to calculate the area of the larger rectangle. Notice that it will be c minus a, which I would just take to be the length, and f minus h as our breadth. Notice that both of these terms are integers, and so the area of the rectangle is an integer. And what that tells us is that the area of the green triangle right here is actually rational. And so we've covered our case for an acute triangle. A similar thing can be done to a right angle triangle. And let's just take a look for the case of an obtuse triangle. For the obtuse triangle, it's just basically the similar setup, except instead of a rectangle, we have this sort of weird shape right here. Well, of course, you can just do a rectangle if we just not overlap this vertex right here and just do something right there, but it will leave some gap right here. However, that gap could also be calculated very easily, and you can notice that that is also an integer, has an integer area, I should say. And well, that also will give a pretty similar result. And I'll just leave this to you guys to prove that the case of an obtuse triangle is also true. So you can calculate the distances right here. You can also calculate this distance right here, and then prove that the areas of the blue triangles are rational, and hence you can also prove that the area of this triangle right here is also rational. Which ends this video.